So the law of sines in 4.7.1 is a really useful set of laws or rules. If you have a triangle that's not a right angle triangle, and you're given a couple of angles and a side, or a couple of sides and an angle, and you need to find the lengths of the other sides. And the law of sines is it's a really simple set of ratios, okay? So first of all, with a triangle, remember that, I'm just going to do this with some colors, so for this angle A here matches the side across from it. And for this angle C here goes with the side across from it. And for this angle B here goes with the side across from it. So for big angle B, the side opposite is side B. For big angle C, the side opposite is little c. And for big angle A, the side opposite is little a. Or you could call this, I guess, line AB. You could call this line AC. And you could call this line BC. You could call them all of those things. Anyways, the law of sines says that the sine of angle A divided by the side across from it, or the length of side A, is equal to the sine of angle B divided by the length of the side B, or the angle, or the side across from it, is equal to the sine of angle C divided by the length of side C, which is the side across from it. So this is what the law of sines is. So for this particular example here, they're asking you to find angle C. So that's angle C. Well, that's pretty easy because the angles in a triangle add up to what? They add up to 180 degrees. Well, they've given you two angles here. They've given you a 65-degree angle and a 69-degree angle, which add up to 134 degrees. So that's like angle B and angle A. So angle C is going to be equal to 180 degrees minus 134 degrees, because the angles have to add up to 180. So if I do that, my missing angle is 46 degrees. So 46 degrees is the size of angle C. So that's my first angle here, 46 degrees. Because 65 plus 69 plus 46 is equal to 180. Now they're asking you for the length of side AB. So here's AB, or you could call that side C because it's across from angle C. How do I find that? Well, this is where I use the law of sines. So I know side A and I know angle A, because the side A is 7 and angle A is 69 degrees. So I can say that the sine of 69 degrees, which is angle A, divided by the length of side A, or side BC, whichever you want to call it, whatever, the side across from angle A is 7. So sine A divided by the length of side A is equal to, well, they want to know the length of side AB. So here's AB. Okay, it's going to be equal to the length of AB, or side C. And that's across from this angle, angle C. And angle C is 46 degrees. So now I can just use algebra to solve for the missing side. So I'm just going to do a little bit of algebra here. So I know that the sine of 46 times 7 is going to be equal to the sine of 69 times the length of AB. So sine 46 times 7 divided by the sine of 69 will be the length of side AB, or side C. And once I've done all of this math, I'm going to get 5.39 is equal to the length of side AB. So the length of side AB, or side C, whichever you want to call it, is 5.39. Then they're asking for the length of AC. Now, if this was a right angle triangle, then we would just know a squared plus b squared is c squared, but we don't know that. So we are going to have to do this same rule again. So I know that, just going to go to my next page here, of sine 60. Now they're asking me for the length of AC. So what is side AC? Here's side AC, which is across from angle B. So I need to have, from before, that the sine, over 7, sine 69 over 7, so that's sine of A over the length of side A is equal to, now they're asking, angle B is 65, so the sine of 65 over whatever the length of AB is. So I'm just going to do the same thing. I'm going to do some math. I know the sine of 69 times the length of AB will be equal to the sine of 65 times 7. So the length of AB will be equal to sine 65 times 7 over sine of 69. So then I know that side AB is going to be equal to 6.7955. So I'm going to round it off to 6.8. So all that you have to think about. Okay, so I'm going to draw you a triangle. So if I have this triangle here, so remember this is not for right angle triangles. This is for triangles that don't have a 90-degree angle, although it would work. So if I have a triangle that looks like this, and this is A, B, and C, or X, Y, Z, or whatever you want to call it, those are my angles. Here is angle A. Here is angle B. Here is angle C. The side across from angle C is this side. I'm doing it in color so you can see what I'm talking about. The side across from angle A is this side. The side across from angle B is this side. So the sides across from the angle, here's angle A. So I could call this little a, but I could also call it BC because it goes from B to C. This is angle B, so this is side little b, but I could also call it side AC because it goes from AC. And this is angle C, so this side is small side C, or I could call it AB because it goes from A to B. So that's how we look at the triangle, okay? So then the law of sine says, and I'm going to use the little a, the little b, and the little c for the length of sides. So sine A divided by the length of side A is equal to sine B divided by the length of side B, and sine C is equal to the length of small side C. The side matches is opposite from the angle. Okay, so if I look at this triangle, let's say this is a 79 is angle A, and angle C is 24. I want to know what is angle B. And let's say side C is 12. Okay, so I want to know the length of side B. I want to know the length of AC. And I want to know the length of AB. Or I want to know side B, and I want to know side A. Okay, so how do I find angle B? Remember, angle B is equal to 180 degrees minus 79 plus 24. Okay, so I know that angle B is going to be equal to 77. So here is 77. So that's pretty cool. So I know that AC, or side AC, or here's AC. So which AC is across from, angle B, so I know that the sine of B over the length of B is equal to, well, I know that AB is equal to 12. So let's call that small side C is equal to the sine of C. Okay, so let's see, I know that angle B is here. I just found that out. So I know that the sine of 77 divided by the side across from angle B, which is here, I don't know that, I'm looking for it, is equal to the sine of C, here's sine C, which is 24, the sine of 24, divided by the side that's across from angle C, which is this one, which is 12. So how do I find that side? Oh, well, I just do some algebra. Sine of 77 times 12, it will be equal to the sine of 24 times, what am I looking for here? Side, okay, well, let's call that AC and AB. So this is AC, side AC. So sine of 77 times 12 divided by the sine of 24 will be equal to side AC. So the length of AC is 28.7. To remember is with any triangle, no matter how funky it looks, if I call this, I'm just going to put them in color again. If I call this Q, R, and Z, the side, so those are the angles, so that's the angle Z, the angle R, and the angle Q. The opposite sides match. So the side opposite from angle Q is that side. The side opposite from angle Z is that side. The side opposite from angle R is that side. And we can name them either, oh, go away, sorry about that. I can either call this side little r, or I could call it QZ because it goes between Q and Z. I can call this side call it R because it goes between Q and R. And I can call this little q or RZ. And then to solve your problem, you just have to remember that the sine of angle Q divided by the length of the side Q is equal to the sine of angle R divided by the length of side R, which is equal to the sine of Z divided by the length of Z, or sine Q divided by the length of RZ is equal to sine R divided by the length of QZ is equal to sine Z divided by the length of side QR. So as long as you have two angles and a side, or two sides and one angle, you can find all the other angles and all the other sides. I hope that helps.